Hey everyone, welcome to another Ampt live stream. I am Jeremy Daly. I am one of the founders over here at Ampt. If you're not familiar with Ampt, which I hope you are now, but if not, essentially what Ampt does is it creates hosting environments for you within AWS accounts that allow you to take advantage of all of the magical AWS built-in native services that they have, like DynamoDB and S3 and API Gateway and Lambda. You can build serverless first apps, take advantage of steady state apps using things like App Runner. You can run long running tasks using Fargate. And the coolest thing about it is you just do it by writing JavaScript or TypeScript, no configuration code, and the system figures out all kinds of really cool stuff for you. Okay. Read all about it. Go to getampt.com and you can learn all about what's going on there. We are live on Twitch and on YouTube, LinkedIn, and on X. So if you're out there, if you're watching, if you have any questions or comments, please feel free to drop those in one of the chats. And hopefully, the magic of live real-time streaming, I can hopefully answer your question, or maybe you can get me unstuck if we get stuck somewhere. Okay, so today I want to talk about a really cool feature that Ampt has, and it is the tasks interface. So today we're going to talk about how we can use the tasks interface to schedule recurring, one-off, and long-running tasks that run in a variety of different compute behind the scenes. So if you go to getampt.com and click on the docs, we have a documentation for tasks. Tasks is one of the interfaces that we offer. And essentially what the interfaces do is it gives you the ability to interact with or interface with some of these pre-configured services that are already set up for you in the AWS accounts that you use. Every AWS account is isolated and so forth. Again, go to getampt.com, learn more about how Ampt works. But I do want to kind of go through the task capabilities and show you what you can do with them. So let's jump right in. So essentially, the way that tasks work, and really the way that Ampt works, Ampt allows you to build event-driven systems. So yes, an API request or a website request, that can be an event, and you can go ahead and load dynamic code, whether that's using something like SSR or an API call using Express or Hono or any of those frameworks that you have, SSR with something like Astro or with Next.js, all of those are all events in a sense, the way that the system works. And you can go ahead and respond to those and again, serve up web pages and do that kind of stuff. But you can also respond to events. You can respond to data changes. You can respond to storage changes. You can respond to all different things. And the other thing you can do is you can respond to tasks or scheduled tasks. So some sort of prompt that says, hey, I need to run this task. And what's really cool that you can do with Ampt is you define a task as a handler. So you just basically define a task. And then from that, you tell it when you want it to run. And it's all done in your code. So you can either schedule that task to run every 5 minutes or on a cron tab or something like that. Or you can actually just schedule it to run sometime in the future. And of course, that can be up to a year in the future, and you can also pass in data, to have the actual task handler react differently depending on what you're doing. So just quickly, in terms of how some of this stuff works here, basically the task interface is from the Ampt SDK. You essentially import the task from the Ampt SDK. You'll define that task. And then you can go ahead and do some information here. We're going to get to all of this, and you can go ahead and schedule that task with something like .every. So if you want to run it every hour, you can say run this every 1 hour. If you want to use cron tab, then you can say go ahead and run this on Tuesdays at midnight. Using the cron expressions. We use the same AWS cron expression format that they use. So you can check out more about that. There's some rules about wildcard and things like that. You can run tasks at a specific time with .run, which I said can run immediately, or you can go ahead and run that in the future. You can use relative times, you can use timestamps, you can do all kinds of things that make that really, really easy to do. And then there's some cool things around timeouts, progress, task history, error handling. let's get to all of this and see what we can do with tasks. There's also another video out there, Introduction to Tasks, that's on our YouTube channel that you can go ahead and check out. It's only 8 minutes long, a little less than 8 minutes long. Gives you a quick overview of kind of what we're going to do and talk about today. But I'd like to kind of dig into a couple more things, and we can talk through things a little bit more. And again, like I said, if you have any questions, please let me know. All right, so let's jump over to Visual Studio Code. And I am going to just make this a little bit bigger so we can see. All right, so I'm going to go into my Git sandbox directory here. This is just a place where I like to create a bunch of different projects. And then I'm going to make a new directory, and I'm going to call this task, and I'll call it Task Master. So I've created this new directory. I'm going to jump into Task Master like this. And then I'm going to go ahead and open this, if I can type. Open this in Visual Studio Code. So this is an empty directory here. If we bring this back up in LS, we'll see that we've got nothing here. So what we want to do is we want to create a new Ampt app. So I'm just going to type in Ampt. Now you could also, it's basically, you're running something like npx/ampt/cli. It's just installing the ampt CLI globally. So I just have it installed globally so we can just run Ampt. So I'm going to go ahead and run Ampt. It's going to go ahead and check for CLI updates, which it does periodically. I'm going to go ahead and use the demo organization. I would like to create a new app, yes, and it's going to ask me what type of app I want to create. So if this was a little bit bigger here, we'd get a more comprehensive list, I believe. Oops, I'm not in there. There we go. So we have all these different starter projects that you can use. There's nothing really configuration different wise. I mean, it's more when you're using like a Next.js app or Astro or one of these other ones, there might be some nuances with your package.json, or there might be some configuration file that's part of that particular framework. So we just give you a starter so that you don't have to kind of set that all up yourself, but you're more than welcome to take an existing project, drop it into Ampt and go ahead and, or drop it into a directory or use that directory, run Ampt. And in many cases, we can go ahead and what we call sort of amptifying it. And that allows us to go ahead and just add a few things into the package.json and so forth to make sure that you'll get a smooth experience when you run it on Ampt. Okay, we're not going to do anything fancy here, so I'm going to literally just grab a blank JavaScript starter, and I'm not going to call it JavaScript starter. I'm going to call it Task Master. Like this. Would I like to use a current directory? Yes, I would. And now this will go ahead and just download that template for me. And then it's going to actually spin up a separate AWS account just for me, load this initial project into that AWS account, connect me to it so that now I can interact with it. So I now have this stylish idea, whatever it is, .amp.app URL, and this is basically my application. Okay, couple things before we jump into that. There's an Ampt ignore. All the Ampt ignore does is just basically say, this is stuff that we don't need for our application. These are just extra files that are there, but we do want to check them into Git and some of those other things. That's neither here nor there. The dev container and the gitpod.yaml, those are if we want to use those, if we want to go ahead and run this application, this dev sandbox, if we want to run this using Gitpod or code spaces in GitHub, we don't need these. So I'm actually going to go ahead and just delete these two things right now, just to make it super, super simple. We have a README file in here, which again, we don't need. So I'm just going to go ahead and delete that. And then essentially we're left with our git ignore, our ampt ignore, which again, really the ampt ignore, we don't even need this now. I'm just going to delete that. I'm just going to make this, I'm going to show you how clean and simple this can be. The git ignore is just saying, don't check in these other things. We're not even going to check this into Git. So again, I'm going to delete that for now. And then our .ampt file is just a couple of things where it tells us like when did it check for dependencies, and then it gives us some log files. Again, this is fine. This won't get synced anyways, but just some information about the project that is available to you locally so that you can see. Okay, so essentially what we have in order to build Ampt, an Ampt project, is we have a package.json. And if we look at this package.json, we're going to see that it is using, it automatically named it this Ampt starter. So if we want to, we can just go ahead and rename this. We'll call this Task Master. Task Master, like that. And this is just an Amp task demo. And then it's private. And then we have a main, this is our entry point. We're just going to tell it to go to index.js. If you wanted to organize your files where you had like a source or a /app directory or something like that, wherever your main index file is or whatever file you want to use, main.js or whatever you want, you just point that here. And we use ESM for our module types rather than common.js. You're more than welcome to use common.js. You just get rid of the type from here or change type to common.js, or you can go ahead and leave it as module and just name your files .cjs, and you can use require if you want to. We like the flexibility of ESM. Hopefully everybody will move away from common.js at some point and just use ESM in the future. So there's a couple of scripts here. One is start that just basically tells it to run the ampt command, and then there's a git pod one, and then you've got the ampt little amp section here that says here's the name of the app and here's the organization that we're running in. That's it. I'm going to go ahead and save this and close this down, and then we have our index file. Now there is nothing in our index file, which means this does nothing. So if I go ahead and I open this link up like this, it's just going to come back and tell me that there's nothing there, not found. That's because we're not doing anything. So let's just quickly show how we could do something with this particular application so that we could actually return something from an HTTP standpoint. We can use Express. We can use any of those other services we want to. We don't have to use anything. If this is just a back-end service, we don't even need to use anything. I'm just going to use Hono just because I like Hono. We also have an API module that you can use, but Hono is really full-featured and works really great. So I'm just going to go ahead and type right from my Ampt CLI, install Hono. Like this. This is going to go ahead and install the Hono package for me. So now we'll get our little node modules and of course, our package.lock, and now we have our dependency here. So in our index file, we're just going to import Hono from Hono. Oops, not Hono. And then we're going to const app equals new Hono like this. And then we'll just do app.get. And a little different than your standard node server that uses, or like Express that would use a the res.rec that just uses C as a context object, and then we just need to return, and we'll do c.html hello from Ampt exclamation point. Okay, now this is unsaved. Down here, I'm going to hit save, and I want you to watch right down here. I think I can actually, can I zoom in here? Guess not. Well, maybe zoom in like this. Okay, like that. So right here, watch that. And when I go ahead and hit save, that's going to go ahead and sync, and a little spin there, and it says last synced 3 seconds ago. Now, if I jump over to my app now and I refresh this, I'm going to click into it, and I refresh this. Oops, what did I do wrong? Gotta do app.fire. That's my fault. Save it, synced, go over here, refresh, and now we have hello from Ampt. So this immediately syncs your code into the system, makes it super easy to have this really, really great development loop. And again, if you put something in here wrong, if I was to do something like return, hello from Ampt plus test. So test doesn't exist. So if I go ahead and try to run this here, I'm going to get an error, and then I'm going to get real-time logs that are going to tell me exactly what went wrong. So reference error, test is not defined, and that was in index line 638. Line 638, right here, test doesn't exist, hit save, come back over here, refresh, and we are live again. So super simple to do that. Okay. We're interested in tasks. So let's go ahead and look at the task documentation and see how we can use that. So the first thing is that we do need to, if we go to defining a task, we do need to import the task method from the Ampt SDK. So we can do this right here at the top, and we are going to have to install at ampt/SDK, like that. So now we have the SDK here. We can go ahead and hit save, and now we've created now we've imported the task interface. Okay, so then the next step here is we have to define a task. So I'm just going to go ahead and use just this default configuration like this. Now, we can put this anywhere we want. We can put this into another file. We can import that into our index file and so forth, just as long as your index file is the main source of truth, where that is importing all the different things that you need, so that the AST can parse all that stuff. But essentially, you can put this anywhere you want. So I'm going to go ahead and I'm going to put all the stuff at the top, and I'm going to keep my API down here at the bottom. So let's define our first task. So this is, I'll leave that for now. But this is defined a task called my task. I'll call this my task, and then it'll say running my task. Now, as soon as I save this, what this has done is this has synced this with the back end. The system has parsed this, and it now knows that you've defined a task in the system because it has run this task interface. So if I was to type open down here, this will go ahead and open up to the Ampt CLI. I'll have to log in here quickly. Oh, and I logged in as that's fine. Reload this, get the latest version of the CLI. Okay, so I'm going to go into here, and I'm going to go into, or you can see right here that we have a task that has been defined. So it's picked up the fact that my task is a task that's defined in the system. Now, it's not scheduled. It's not going to run anytime, but it is defined. All right, so if we go into this here, so now that we have our task defined, now we want to be able to schedule it. So there's a couple different ways that we can schedule it. So let's start with this idea of a relative time. So if I want this task to run every hour, every minute, something like that, I can use this .every command like this. So I'm going to go over here, and I'm going to say my task, and I want it to run every, and I'm just going to say 1 minute. And I want it to pass in foo bar. Okay, so one of the things that we can do here is we can, we'll log out what the event is that is being spit out. So I've saved this, and if I go back over to this here, we'll see that we now have my task that is set to run every minute. So this just picks this up automatically from your code, right? So nothing special you have to do to configure that. You're just basically saying, this is what I want to happen. And now what should happen is every minute, and hopefully we don't have to wait too long for that to happen, it should go ahead and run this task for you. Now, one of the cool things you can do, and it just did, which is nice, and essentially what this is saying is running my task. That's our log, and then we have the details of the task. So it tells you what the target was. In this case, it's my task. It gives you an ID of the task, which is the same as the execution ID. You've got the name of the task that runs. You have the configuration of the task. So again, you can set the timeout. By default, it times out after 30 seconds. How many times you want to retry that task is automatically built in here. You can set those attempts. And then you have the body, which is what we sent into the task. And the reason why the body is important is because let's say that we were to go ahead and define a task where we said, all right, I want this task to run, I'm just going to make it so it doesn't run on us, so 1 hour. So we want this to run every 1 hour, and that's going to send in, I'm just going to say this sends in foo, how about I send this in timing or something like that, and we'll call this hourly, and then I want to schedule the exact same task to run once every day, and the timing on this one is going to be daily like this. All right, so what's cool about this is now when I go and I look here, I'll see that, did I save it? Yes, I did, okay. So this should now pick up that I have my 2 tasks here, one that is my task that runs every hour and one that's my task that runs every day. So if I run this task, which again, you can go ahead and fire off for these tasks to run if you want to test them. Again, this is, if you're scheduling something to run, every Tuesday at midnight or something like that, you don't want to have to wait for that to happen. So you can actually kick those tasks off to run. I'm not sure why that disappeared. So that'll go ahead and run that task and give us this information that says, here's the body, the timing is hourly. Now, if I come back over here and I want to run the one that runs every day, I go ahead and I click that. That goes ahead and fires that task off. And now I'll see that I get, it's probably running the hourly one for me. But so I'll go ahead and get the one that says the timing is daily. Oh, I think I might have clicked it twice. Either way. So this will go ahead and give me not only how many attempts it is expecting to get, but then what attempt it actually is on. So that's just nice too. So you can say, oh, if this is the second attempt, maybe I want to check for item potency or something like that. Okay, so that's pretty straightforward. Cron tabs is essentially what this is. It's just a sort of a shortcut to building cron tabs. So that's one way we can do it. The other way that we can do it is we can go ahead and use the cron syntax. I'm just going to clear this out. So we go back over to our documentation and we go to scheduling tasks with cron. This just gives you the ability to use that traditional cron expression, right? So this is the every Tuesday at midnight. So I'm going to go ahead and copy this. And I'm going to go and say my task .cron. So again, this is every Tuesday at midnight with foo bar. And then if I wanted to do, this is midnight. So if I wanted to do every, I guess, Wednesday at 8 a.m. or something like that, I can do that. And then again, this will do the same thing where over in my system here, this will pick up and tell me that my schedules, or it should, give it a second here to update. There we go. So now I see my crons and I have Tuesdays and Wednesdays and so forth. I believe both of these say foo.bar, so this one should say foo.baz. How about that? And I come over here, I can run this one, that will run, and that will spit out foo bar, and I can run this one, and that will spit out foo baz. So it's there. So quick that it is there. So anyways, so that's a way that you can run schedules on a regular basis. Maybe it's an ETL task. Maybe it's something, that it's just a simple cleanup. Maybe every 10 minutes you check some queue somewhere. You pull some remote queue or something like that. So you've got a lot of capabilities just with this here. All right. The other thing that you can do, which is pretty cool, is the ability to go ahead and run tasks as one-off tasks. So if I go here, I'll clear out that. So if I go over to the documentation and we go to running tasks at a specific time. So the first thing is that we can just trigger a task based off of something happening. Right now, we can just call that, whether it's on the other end of an API request, whether it's an event, whether it's a data change, whatever it is, we can just go ahead and call the .run method. And all you have to do is just literally call .run. So I'm going to use our our API endpoint here to go ahead and run this task. So I'm going to say const, and I'm going to say task info is going to be my task. Right, that's what we called it. My task .run. Okay, so I'm just going to send this for now, and then rather than returning this as HTML, I'm going to change this to JSON, and we're going to say my message is running tasks on Ampt, and I'm going to spit out the task info like this and save that. Okay, so now what this is going to do, and this would be helpful if I await this because otherwise that's not going to help, which means I need to make this async. Okay, so what this is going to do is when I hit this get route, it's actually going to trigger this run. Now, what I'm not doing is I'm not passing anything in here. So I'm just going to start with, well, let's say, I don't know why it always pops up with foo, but I'm just going to say foo, and it's going to say hello from API trigger. How about that? Okay, so now if I go into my configurations over here, I have my task, but I don't have any schedules or anything because I removed those. But now if I hit my API, it should go ahead and run this for me. So I'll go over to this here. I'm going to hit refresh. And then I should get message running tasks on Amp with a task info, which returns the ID for me. And then if we come over here, we'll see that that task has immediately run. And it will, again, give me all the same information, including that task ID, configuration information, and then I get my body as foo hello from API trigger. And what's cool about this is that if we did want to say, I don't know, let's say we'll say query, and I have to remember if this is the way that it works. I think it is. Yeah, sure. Name, how about that? We can say name equals, oops, query. I guess I could just say, make it easier on myself, just say name, how about this? And of course, we would want to check that. And I think this is, I always forget how some of this stuff works with, oh no, I think it's just c.query. I don't think we have to await it. All right, so then this case here, then what we should be able to do is go over here and do name equals Jeremy, hit enter, and we get an error because cquery is not a function, which makes sense. So let's look up Hono, and don't know why. I can never remember this, but all right, so the API, we want the routing, no, we want the Hono request, and we want query param, we want query, c.rec.query. So simple. c.rec.query is the name. Save that, clear that out, come over here, refresh this. Here's a running on task. There's our task ID. Name is outputting as Jeremy, and then when it runs a task, it sends in that information. So the point here is that you can send dynamic information into a task handler, either even if you run them right when you run them. Okay, another thing that's interesting about tasks is when tasks are run using the .run. If we go into the tasks interface over here, and actually I think whenever a task runs, yeah, we'll get all the runs for them. You'll see that there is information about the task. So it is when the name of the task, the current state that the task is in, when it was submitted, when it was completed, and if you click on the drop down here, you can get a whole bunch of detailed information about the task. So we get the execution ID, how long it ran for, some lifecycle events, what the input was, and then what's really cool that we can do here is let's go ahead and go back to our code and say that we want to run this task, but we don't want to run it immediately. We want to give it some time to run or before it runs. So you can go ahead and send in a time. It can be a relative time. It can be whatever you want it to be. It can be believe the accepts, a number of milliseconds to wait. It can be an epoch timestamp in milliseconds. It can be a string containing a date in UTC format. It can be a JavaScript date object, or it can be a string with numbers, with a relative time. So for example, if I said, I want this to run, but I want it to run in 1 minute, like this, and I'll just going to output the name here too so that we see this as part of the JSON response. So I say I want this to run in 1 minute. I'll go ahead and clear this out and come over here. So now I'm going to hit run. That didn't, I didn't save it. Okay, hold on a second. Let me save that. Clear. And I'm going to go ahead and hit run here. So this gives me the name and so forth. And now if I jump over to the tasks and refresh, I can see that this particular event is scheduled. If I go in here, I can actually cancel this execution. So I'm not going to do that yet. I'll let this go ahead and run, and it should run in a minute. So, and you can see, by the way, that it logged Jeremy because we are console logging here. This is just super helpful. It gives you real-time, real-time results or real-time data logs. And of course, these logs can be debug logs. You can set your debug level, some of those things, so that you see different logs in the development environment versus what would actually get logged in the production environment. So we're not logging a bunch of other things. So it's been about a minute. So this should go ahead and trigger at some point soon. Let's see where we are over here. Refresh. Still scheduled. Okay. And has it been more than a minute? There we go. So that fired off, and now we go ahead and see that this task ran. It gives us the timestamp of when it ran, and so forth. So just really, really handy to be able to schedule those tasks into the future. And then again, if we wanted to run this one more time and hit refresh, we're going to run this again. And then what we can do is we can go over into our tasks here, refresh this. We've got the scheduled event, come in here and say, oh no, I don't want to run this. So again, this is super great if you've got something running like, in the future later on. Okay, so a couple different things that we can do as well with tasks. So we've seen these tasks run for relatively short periods of time. We can do much longer if we want to do much longer. And again, now we shouldn't see that task is run again, by the way. But before we do that, let's just do one thing with the information that we get about a task. So I'm going to go ahead and change this to run in 5 minutes so that we get a little bit longer, that we can kind of play around with some of that stuff. And then what I'm going to do is I'm going to create another endpoint. That'll be an app.get, and we'll call it tasks. Sure. And what I want to do is I want to get information about the tasks that are running. So actually, I'm going to go ahead and do task, and then I'm going to call this task ID like this. And then again, I'm going to look this up, but task ID crec param task ID, is that the right way to do that? Let's make sure I get this right. crec param ID, yeah, so that gives us that. So this is going to give us the task ID, and then we want to go ahead and get information about the task. Task.get is not, good guess, but that is not the right thing to do. So if we want to get task history, we can go ahead and call the task status. So I'm going to change this to await get my task.status. And actually, yes, so we do have to await the task status of task execution. So we don't actually need to use the progress task history. So we don't need to know the name. We don't need to know the task that we're trying to get the history for. All we need to know is the execution ID. So we actually want to await just on task itself. So we'll use the task interface to do that. We'll do task.status. So maybe we call this task status like this. And then this will say task status. And then we'll spit out the task ID as well as the task status like this. Okay, so we can take an existing execution ID, like this one, for example, copy this, and then we have this new /task endpoint. So if we come over here, let's actually open a new, oops, I just kicked off another tab. Oh, well, that's fine. Anyways, I'm going to kick off another, let's see, I want to take this here. Oops. There, and this is going to be /task/ID. And what did we do wrong? Because we just did /task. Okay, so /task like this. Okay, so then now this is giving us the details of that particular task. So this is telling us the name, the name of the task, what the body was it, what the current state is, when it was created, when it was submitted, when it was started, when it was completed. Gives us a whole bunch of information about the task. So that's really helpful because, for example, we just kicked off this task here, which if I copy this task ID and then go and look at our tasks here, we should have, I believe, a scheduled task right now. So we have this scheduled task with an ID. So if we come over here and we want to look at this particular scheduled task, we can run that. Oops, wrong number. And this is telling us that here is the state it's scheduled. Here's when it's created. Here's when it's scheduled at. So basically, we have all this information available to us that we can go ahead and use, to understand what's happening with the task. And then some of the other things that we can do. Here is, so this is just giving us all kinds of information that we can see. And so there's a bunch of stuff here that we haven't gotten to yet. So we haven't seen failed or progress message or error message or result. So actually, let's do that. So I'm going to go into the task interface here. I'm just going to go ahead and cancel this task. We don't need this one to run. So cancel execution. Unless it, no, it didn't run yet, right? Okay. Cancel. Okay, so that's canceled. All right, so let's go in and do a result. So if I come in here, so now let's say that we want to run this task, and then rather than 5 minutes, I'm just going to go ahead and have it run. I'll just have it run immediately for now, just to make it a little bit simpler. So one of the things that I can do is from my task itself, so this is my task definition. And again, we're not doing anything in this task, but you know, obviously we can make external calls, we can, you know, query data, we can do whatever we want in this task. I'm going to actually return, I'm going to return a result. So I'm going to say success is true. I believe you can return basically anything you want from here. But this way now, when I run this task, and I'll go here and run this with, I don't know, let's say Jane. I'll run that. So I've run this task. This should execute immediately over here. And we'll see this run. So we have the running my task. This is my task. So Jane. And then what's nice about this is, so this gives us the output of what the event that was set to run this actual task, right? The details of the task actually running. And then I will get over here. Let's go over here. I will refresh this, and now I'll see that I get this success equals true. So I can get resulting information, so I can see the input, I can see if it outputted any specific information for me. And then what should happen is if I grab this execution ID here, and I was to load this execution ID here, oops, there's no EX here. Try it again. No, I guess there is an EX. Why is that not loading? Grab this. Okay, so now I'll get the state, the body, and the result. So all that information is saved with that task, and I have that history. So if I wanted to query that task later and check what the result of that task was, you know, again, it can spit out specific information. I can go ahead and use that. I can parse that information, and I can do something interesting with it. So it's just super helpful to have that. The result, I think, can be anything, and again, you can then parse it however you want to parse it. Okay, so up until this point, tasks have been running in Lambda functions, right? So essentially, we're serverless first, right? We want things to run as serverlessly as possible, so that you don't have to worry about setting up, you know, servers and having a whole bunch of stuff running in the background that you're paying for that you're not necessarily using. But one of the things that we also do is we do allow you to run long-running tasks. So if you wanted to run something on Fargate, for example, then what we can do is we can just go ahead and set a longer timeout. And the way that we've done this right now is you essentially define your timeouts, and you can see from the documentation here, if you go to timeouts, I was already on it. You set the timeout like this, or you can actually set the timeout in the actual task itself. So what's kind of cool about that is, let's say that you're running a task and you realize, oh, this task is actually going to need more time because it went down some particular path. You can then dynamically change how long it will allow that task to run for before it times out. If you do have a long-running task, you do want to set, you know, if you think the task is going to take a minute or more, you do want to make sure that you set a timeout that is appropriate, at least in the beginning, something that is part of it, because then you can run a task for up to 5 minutes in a Lambda function, is the way that we've got it set up. But if you wanted to run for up to an hour, you can run that in Fargate as well, and that will run. So as long as you set the timeout to be more than a minute, it will go ahead and it will provision Fargate for you. So let's go ahead and take a look at that and see how that works. So this is saying, you know, so this 120 million. Is that what it is? 112 million, 1.2 million milliseconds. This is in seconds, right? Yeah, it's a change of default. This is in milliseconds. Sorry. So if we want to go ahead and grab this, and we'll say let's just give this task the ability to run for 20 minutes. It doesn't have to be 20 minutes to trigger Fargate, but let's just set it for 120 minutes so that it is there. So when we do this, this will now run this task in Fargate for us. And I'm trying to think of how I can show that to you without jumping into the AWS account. But essentially, let's go ahead and run. Let's just run this task and we'll do it that way. So this is set to run immediately, and I will go ahead and come over here and change this from Jane to John, and then I will go ahead and kick off that task. And I did save that, right? Good. Okay, so go back up here, look at our tasks and refresh, and now we have this task submitted. So one of the things about this is that you probably noticed with other tasks is when you submit them, they run very, very fast, because if it's under a minute, it's going to go ahead and just run that task for you in Lambda. But there's a reason why you don't want to run tasks that potentially take quite a bit of time to run, why you wouldn't want to run them in a Lambda function, because Lambda compute gets kind of expensive. And so if you're doing a longer running process, and you want that to run in the background, it's usually a little bit better for you and more cost effective to run those in Fargate, and you don't have to do anything extra here. So this still says submitted. So it usually takes somewhere around 30 seconds or so for a Fargate container to spin up and for those things to actually kick off. So there we go. So now that's run. But this ran in a Fargate container, which is why you saw that it took a little bit of time for the scheduled bit to run there. So we should see those results pop in here as well, because those are completed now, and that should spit all that stuff out. I'm not sure why we didn't see it here, but we should, maybe just a little bit delayed. But essentially you have those logs as well as part of the Fargate task that are, actually, no, you wouldn't see you wouldn't see those results in real time with the Fargate task because that runs in a separate process. But anyway, so you have the capabilities to then run those tasks, behind the scenes that way. Okay, a couple of other cool things that you can do with tasks that are sort of, pretty helpful thing that you can do. I'm going to change the timeout. This would work with Fargate as well, but I'm going to actually just set this to run for. Let's set it to run for 59 seconds, like that. Okay, so that's 59 seconds. Okay, so this will run for 59 seconds, but what we want to do is we actually want to return some sort of progress information as the task is running. So I'm going to go ahead and just create and I know, see if I remember how to do it. Set timeout. Timers.promises. Okay, so in my task itself, I'm going to, first thing I'm going to do is I'm going to say I'm running my task and I'm going to spit that event information out. All right, then the second thing that I'm going to do is I'm going to change this task event handler to be asynchronous, which again, we should have done in the first place, but that's not that big of a deal. And then I'm going to write, I'm going to do await. And then I'm going to set a timeout here, and hold on, I gotta just check my thing here. What I want to do is send progress updates. So I'm gonna copy this, and in my event here, I'm going to load this context object. And then what I'm going to do is I'm going to await a timeout, and I'm going to just wait 2 seconds here. And then I'm going to go and spit out something that says, processing, or I don't know, 1/4 there. And I'm going to do 0.25. And then I'm going to set another timeout, and we'll set this. Well, let's set these to like 3 seconds each. How about that? And then we'll say 2/4 there, or 2/4. There we go. Fractions, halfway there. This will be 0.5. And then we'll say 3/4 there and 0.75, like that. And then we'll return that it was true. Okay, so now what's cool about this, assuming that I coded everything right, is if I go over here and we're going to run this again, and we'll run with a different name. Let's run with Julia. So now I submit this task. This task is submitted. All right, and now the task is running. So the first thing that we saw was that it spit out this information. And then I might have not given us enough time to do this, but if I refresh, we see that this task is started here. So it's, and it already completed. Progress 75. Okay, so actually I'm going to change one thing here so that we can see this. Is I'm going to go ahead and set this to 1. And I'm going to say done, like this. And let's make these a little bit longer. So let's do 10. Is 10 seconds too much? It might be too much. How about we do 10 seconds for the first one? Yeah, we'll do 10 seconds for the first one, and then 5 seconds for the other ones, like this. Actually, yes, okay. All right, so let's try this again. Okay, so I'm gonna go here. Let's refresh this so that we get a nice clean view. All right, and so now let's trigger this one again, and we'll say Julia 1. We'll trigger this, and then we come over to our task and we refresh, and we see that it started, and then we can see there's been no progress events yet because it takes a second. So well, I think we did, what did we do, 10 seconds? Okay, so now we have a progress update. So last message, 1/4 of the way there, progress 25%, progress 50%, progress 75%, progress 100%, and the task is completed. So anyways, just a cool little feature that that you can use in order to send progress. Now, obviously, on a small task like this that only runs for a few seconds, it's probably not the not super useful. But let's say that you're running a, I don't know, some sort of deployment process or an ETL task that has to download a bunch of data and do a bunch of calculations and and give you all kind of status updates. While that code is running, you can certainly go and check the logs, and you could watch the logs for that particular task and watch the logs coming back from that task. But the problem with that is that it's kind of, if you've got maybe 10, 15, 20 different, tasks running at the same time, how do you kind of go in and keep track of that? And it's hard because, again, you have to kind of sift through the logs and find it. Now, if you go into the logs and you go into the task logs here, we will see all the tasks that run, how long they take to run, and so forth. I believe this is, I believe we do aggregate, the logs will show up from your Fargate containers. They will show up in the logs. They don't show up in the real-time logs, but they do show up in the logs here. So you will see that information, but of course the actual task information is updated behind the scenes for you as well. And so one of the cool things you can do is that you, again, can write scripts that literally monitor this stuff if that's what you wanted to do. So if we go back over to the code here, the first one takes 10 seconds, and we have our /task route as well. So we can go ahead and let's kick that off again here. So we'll go ahead and we'll say, I'll go back and run this under Jeremy. So I'll run this here. We're running a new app. I'm going to copy this, quickly jump over here because we didn't give ourselves a ton of time. Paste that in. And now I see that the current state is started, and I refresh, and now I see this progress meter. So as I'm refreshing, oh, now I'm halfway there. All right, refreshing. Okay, now I'm 3/4 of the way there. And refreshing. Oh, now I'm done. Now again, from your tasks, you can, when a task is completed, if you want to actually have it fire off an event that tells it to go do something else, or maybe when you update these progress messages, you want to do something else. but it just gives you a lot of control, over what's happening in the task, and all of that information, and all of the logging and everything. It's all built in for you, so it's nothing. You don't have to write anything custom to make this stuff work. But it still gives you a tremendous amount of flexibility. Okay, so we talked about timeouts, we talked about progress, the task history we went through as well, all the different information you get about that. We talked about running at tasks at a specific time. The only thing we didn't talk about was error handling. So the way that tasks work right now, so when you schedule a task and it goes to run a task on a schedule, it will attempt it multiple times, 3 times by default. But if it is a task that you just run outright, and the task, like scheduled for the future, and the task fails, it doesn't retry right now. So that's one of the things that we're kind of curious, because we don't want a task, especially a long running task, if it's a 20-minute task and it fails, we'd rather you go and figure out why it failed as opposed to just retrying it. So that is something, though, that you can do, where again you can monitor your tasks, and if your task fails and you want to go ahead and retry it, you can do that. So anyways, that's tasks. Pretty straightforward, and like I said, it is built in, where it gives you, all of this stuff is just built in for you, right? So a lot of flexibility in terms of when you want things to run, flexibility about scheduling things in the future, just some of the workflows that you can build off of it. Again, we use the HTTP interface in the sense that you're using, you're listening for an API request, but if you look at something that happens within a event. So if you want to send events back and forth, you want to publish an event, you can go ahead and user sign up, right? So a user sign up event, you fire that event off, you listen for that event, something happens there, and then you decide, okay, now I need to kick off some long running task to onboard this user or do some setup thing or whatever it's going to be. Maybe somebody uploads a file, and you have a task that you want to kick off when they upload a file. Now, when you upload a file, you can you can have listeners, right? But there's timeouts where essentially, again, we don't want these timeouts to run, or we don't want these processes to run for a long time on Lambda functions. It gets, it can kind of get expensive. So we do set a limit. I believe so there's a 5-minute limit to, reacting to a file. But maybe you want to go ahead and say, okay, this file has changed. Now I want to submit some work to be done in the future. Tasks are a great way to do that. They can be a one-off thing. And again, you get more visibility into that task running, and you can see kind of how that works behind the scenes. So there's some cool things that you can do there. Again, you kick something off on the other end of a WebSocket. There's a, data module is very, very comprehensive. There is a whole thing on reacting to changes in data, so you can listen for created events and for, updated events and things like that. So if some data gets updated, that requires you to kick off a long-running task that does something else. And of course, from within your tasks, you can send and publish messages, you can write data, you can do all kinds of things, that gives you a lot of power over what the workflows are that you're building, and build some pretty cool data-driven or event-driven applications. So, okay. So that is tasks. That's the overview of tasks. I hope this was useful, and you find some cool things to build. One of the things that I didn't show you, and I guess we got a couple more minutes. Let me go ahead and just show you this quickly. So this task that I wrote here that does all of this calculation stuff for us, the whole deal, this right now is just running in my developer sandbox, right? So if I pop over here into, oops, I didn't mean to do that. Let me go back into the taskmaster here. So this is just one sandbox that's running. I can hook this up to CI/CD using Git, or I can hook up to my GitHub account if I wanted to check in code and build preview environments. There's all kinds of things that I can do. But one of the things I can just show you quickly that we can do here is I can go ahead and run a deploy right from my CLI, and I'm going to deploy this to a new environment called dev. And so this is going to be a permanent stage. I can also create preview environments. There's just so much you can do, and it should all be really straightforward once you understand the workflows. But so I'm going to deploy this to a new environment. So this is creating an entirely new AWS account, completely independent of the developer sandbox that I'm working on. So this takes, it depends, somewhere around 20 20 to 45 seconds, depending on how complex the actual system is itself. But so what this will do is once this is done, and if we jump over here, we'll see that this has now created this new environment. It hasn't registered any tasks yet, right? So it's still in the process of deploying, but it's created that environment. So now this has been deployed, took 38 seconds. We come back over here, and now you'll see all of the information that we had over there. But you'll also see that this task history is empty. You'll see that the URL here is a different task. So if I wanted to copy this URL and go over here, and I'll paste this in, and we did $name equals, let's do Beth. Oops. So Beth, we'll hit enter. This will go ahead and run this now in an entirely different environment. So this has now kicked off a new task in our dev environment. Over here, if we refresh this, we should see that we have this new task started. Again, we are reporting progress on this. So as we, oops, I didn't want to refresh it like that. I wanted to refresh it like this. So we'll see those progress messages that are being updated. This is running in the background. All of this is happening there. And what this is doing, this is in a completely separate AWS account, completely isolated, right? So you can continue to make changes to your development environment, play around there, and then only when you're ready do you push those changes. So now our task is done here. And again, if we look at this now, we have two separate running environments. And you can create a bunch of different stages. You can create your preview environments. You can do all that stuff. So the workflows here are pretty powerful in terms of, you can experiment, play around with it, get it working exactly the way that you want it to get working, and then go ahead and move it through, through the CI/CD or, whatever you want for that process to get it into production. But that's it. No configuration, nothing fancy that you have to do. Just takes care of it for you and basically gives you a hosting environment in AWS, in an isolated AWS account that uses all of those magical AWS primitives and services. And we essentially build all those productized patterns behind the scenes for you to make sure that it runs solid and you don't have to worry about it. So anyways, okay, like I said, hope this was useful. Check out Ampt. There's a whole bunch of docs here. We've got, fair amount of blog content and some of the other things that we've done. We have an entire template library that gives you a bunch of different templates to get you started with stuff. But I'd love to have you sign up, give it a try, send us feedback. Just trying to make it better, make it easier to work with AWS, especially for a lot of the things that a lot of things that are just the same stuff over and over again, rather than you trying to figure out, what do I use here? What do I use there? What are all the infrastructure as code that I have to write? We're trying to simplify that process. So anyways, let me know what you think. And we will see you next week. Thanks for joining us.